Hey guys, it's Andy here. Alright, so in this video I am going to show you how I built this power wall. It's finished now, supposedly. There's problems, but you'll see in the video I ran into a lot of different small and large issues. It was a lot more of a challenge, but it turned out really nice. I'm very happy with the overall completion of it. Shout out to Dawi for asking for this video. I was working on it, but I was actually probably not going to release it for another few days at least. There was a lot of issues to getting to this point. A huge change from this design, right? And even this one over here, right? So, hope you enjoy the video. Like, comment, and subscribe. Let me know what you think. I really appreciate all the feedback, all the criticism. It helps me create a better product, and you know, I greatly enjoy this stuff, and I enjoy sharing it with you. You're gonna need to build a jig. This is mine. So basically, it just holds it in place in 3 spots, and then leave the other one open. So once you're finished, you can slide it out. Basically. So you'll get these in the mail. Should look like this if it's from Alibaba. Just pretty well packaged. And then you properly put them out on your jig. Set them out. Should be really tight. And then once you have them out on the jig, then you might want to hot glue them. Right, I set this up. So you might want to hot glue the joints. I found it's kind of nice to hot glue the joints first, because then it pushes your wire up when you string your wire. You want your wire to be up high, so you don't want the wire to be sitting flat on the plastic. You want the wire to be up, like near the tip. So you start off with this guy, okay? So you wrap it around there a bunch of times. This is really hard for me to do, but basically you just zigzag it really tight and it pulls all of them together. But you want it to be up high. That's why it's good to do your hot glue first, because it'll be sticking up a bit and it'll push the wire up near the tip. Also, you'll want to put a lot of flux on all of it, because like even if you get a tin of it, you put it on your finger and then you just wipe it across all the tips. It'll help keep the wire stuck to these legs a lot better. But you basically zigzag it, you know, running it tight. It's a little tricky. Once it falls off, then it's a lot of screwing around. But basically you zigzag it, you have your flux on there, and then you solder it. But try and keep it so it's near the top, right? If it's sitting down flush like that, if it's right down, you're gonna melt the plastic while you're trying to solder, and you'll get a cold joint. So get it up near the tip. It's gonna be difficult, but I did it. I didn't have too much of a problem. You know, just use a really small flat-headed tool. Like, you figure out which one of these will work fine for you. I'll film this since I'm about ready to flip her over. Okay, so I soldered up all the points. Okay, I used hot glue on each spot that there is a connection point. Just jam it down in and fill it up carefully. So every time there's where they connect. Bottom is gonna have these tabs here, and then the top I left like this because it will connect directly into these breakers. The hot glue should hold it together till it gets flipped over, but I'm gonna have to tape this and cover these up. And then you have to use these screws. They're a little pricey in my opinion, considering what they are, but you gotta buy these, and they have to be this kind. They cannot be, you see it down there? There's a mushroom head one. Do not use those. That one there too. Alright, they have to be this. They have to be a wedge shape. That's the most important thing for when you're screwing these down, because if it's a bumpy head, the battery can't sit down in there properly, because there'll be a bump. Instead, this is almost flush with the plastic. Pretty much boom, 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 boom. So 4, and then 4, right, 1, 2, 3, 4, and then in the middle, you want to try and do the middle, another group of 4, and you try and lift it up, and it's pretty secure. Right here is a little weak, in my opinion. The rest of it, yeah, right here, I think I want to put one, just for safety's sake. I got this bolted in. I have these kind of set out where I want them to be, and I'll mark them off. I'm still trying to figure out how to deal with this. I got this put in place. Got this one going. So, changed the wiring diagram I made. And there will be holes, yeah, there will be holes through here so that I can actually stick the bolts up. How I'm going to secure the bolts, I don't know. I'm going to have to figure that out. Something that's insulated so that the bolts stay in place but don't make a mess and don't short out. It's fine. I made a lot of mess when I first cut it out. It's pretty messy. And then I finally remembered that I actually have, I don't know why, because when I was planning out this phase, I even told myself, hey, you've got an X-Acto kit knife, make sure you use it. I get home, and what do? I use a fucking box knife. I don't know why, but you know, it's prototyping phase, so it doesn't even matter. This was just lying around. The nice thing is once I'm done this one here, I can then redo this whole one, and I'll know what the hell I'm trying to do. I'll know where to put stuff. I'll have a better idea, because this is pretty damn ugly. I mean, to quote my grandma, it's pretty ugly. Like, and then I'll redo this one too. It doesn't have much room, but to be honest, like, this will be removed, and this heat sink will be removed. I'm pretty sure this BMS actually does balance, because I look at the specs for these BMSs, and they only start balancing when you hit 4.18 volts. So when the battery hits 4.18, then it starts balancing them. Okay, at this point, it'll be a miracle if I don't mess this up. I had to buy a new soldering iron, but I got it for 30 bucks. And it feels a little bit better. So the wood is good for stabilizing stuff. It would be nice to have another piece of wood right here, just to help stabilize, and then maybe one here and one here for this back plate. It's been a nightmare. I feel like I've wasted a lot of time on this, mostly on this front plate, but it's not a big deal. The cigarette lighter, it'll be mounted in. A bunch of these voltmeters don't work, but I have more coming, so that's okay. I had to notch out a lot of parts, so that's notched out, and that's notched out. As soon as I pull out these ones, they start flickering. So I think these voltmeters, they're just a bad idea straight up. When I build my next plate, it'll probably be using this plastic here, this corrugated plastic. It's better to have this than to have using plexiglass so you can see behind it. Plexiglass is too expensive as well. The way I mounted this is because this guy was way too long. I used an L bracket that I cut. Right. Then another one that's secured this way, and it's very, very secure. I'm quite happy with that. You know. So yeah, I'm happy with that. It's not perfect, but I'll probably redo this whole faceplate and throw this one in the garbage. It's not the best, but I do like having this, these 3 lugs, and then this. Alright, you can see the shunt right here. It has a nice thick ground wire used, which is fine, but for this one I doubled up. I used 2 wires that go underneath here, and it pushes this whole frame up. and for some reason it's not working. And this one just fried as well. I had 2 screens fry on me now. No explanation why. I know they're fried because I can feel the heat build up. I only needed 1 wire. Like, this thing is not going to be running any high loads. At most, there's going to be a few amps running through this thing. Its only purpose is balancing. This was pretty easy, like this. You can look up videos. Lots of people do it. They use a vise and they use a drill to spin it together, and then just runs out through here. I use shrink wrap. I bought a whole bunch of shrink wrap, so now I can make things look really nice. I use a block of wood and a lot of shrink wrap and electrical tape, so this bolt is completely isolated from anything. One big mistake I made is I shouldn't have been soldering to these points. I should have made legs sticking out the bottom so that I can solder onto these legs. So it'd have to stick out to about here all the way along. That's what should have been done. And then these guys, these voltage meters, they were a bad idea. They're very inaccurate. They're not useful whatsoever in my opinion. They vary wildly. This guy, I like this one being green and this one being red, but I have a whole bunch of red, so maybe I'll just paint future ones a different color. I made these wires long enough so you can flip this whole front panel back. You'll have to do your own deciding on how thick your wiring is. This grounding wire, that's perfect to use. I strongly recommend using the grounding wire for any straight runs. Like I used it here. It's good here. And anywhere where you have these big lag bolts, this really thick grounding wire, if you can get a bunch of it, you can get it from construction sites for free. It's this big thick stuff here. It's very stiff. That's its only downside, is it's very stiff, but it's very good. And then this is the other stuff. It's in comparison, it's not even close to as thick. So I had a lot of problems with these voltmeters. Terrible idea. I really can't recommend it at all. I had troubles with the wiring for it to sense the voltage, because you have to have the negative and the positive. So you'd have to have some weird dial. But anyway, so this, I use hot glue. Just tack the corners only. Don't do what I did and keep filling it in, because if you ever have to replace it, it's a bit of a headache. And then I have an on-off switch. Here's a really big problem. I fried 2 of these boards before I realized that these 2 have to be bridged. If they're not bridged, it'll melt. It'll actually like start melting the plastic. Something goes on, I don't know what. But yeah, basically they have to be connected and they have to go to the negative side. Okay? Just be really careful with that. Another point is when you're prototyping, when you do this for the first time, just use this cheap styrofoam paper board. And then if you want to use acrylic or some kind of really fancy material, then once you're comfortable and you have a good template, because there's a lot of things that are not perfect in this design at all. Like BMS, I think it's the biggest issue, but it's easy to swap out the BMS. It's not an issue. With the new one, I'll have to add another switch, a spot with a switch. I had to add a switch for this guy because I want to be able to charge up my cell phone. And these guys linked in the description. All these parts are linked in the description. You can just go to a junkyard, old car lot, and you can get these cigarette lighters for free, pretty much. Or like where I live, you pay $1 to walk in there, and then you just like rummage through all the vehicles, find like 4 or 5 of them, make it worth your time, and pull all these cigarette lighters out. And then you can use them for projects, you know, and then just, I don't know, you can decide what to do. One really tricky part, I kind of debated this, was I used this this stuff right here, comes in big rolls. I used it and I covered it in electrical tape, and then I used the existing holes. But then you have to use a lot of electrical tape or liquid tape. I would recommend liquid tape. Not this stuff, the black stuff is better in my opinion. The green stuff was a little too expensive, but either use liquid tape or electrical tape, because you have to make sure that the screws aren't connected here, so you have to use your multimeter and do a resistance test. So I did a bunch of resistance tests, and these screws, you don't want them to, you know, be like these screws to be live to this, just for safety, just in case. It doesn't actually matter, but I would strongly recommend it. I really don't like that I had to solder onto legs for the voltmeters. I really liked using the wood. It was very simple. Drilling the holes and then cutting them out was a little tricky. I had to drill several different size holes, and then I used my Sawzall to like notch this out, and then I used a flat-headed screwdriver to pop all the pieces of wood out to make these notches. And I couldn't find like enough of these big long bolts, so I had to use a short one, so then this one had to be a bit higher up. Probably the most difficult part is cutting the hole out, this hole out for these guys, and this guy. I would almost recommend measuring it really carefully, like use a digital caliper. Measure it out like crazy. Don't screw the breakers down first. First cut the hole, like measure it out where you want it to be. Then cut the hole out perfectly so this fits in, and then mark out the holes and then screw this down into place, because I had a lot of trouble trying to get those, but that was the only place that I had a lot of trouble. I had to also notch out for these bolts because they were just a tiny bit too high. So right there and there's for the shunt. Kind of convenient to put a wiring diagram on the back of this. At first I was thinking that this board would be a real hindrance and a headache, but halfway through, once it started taking shape, I was like, okay, this is actually beneficial to do it this way. So I got used to it, and I was happy with making the decision, because, you know, other than it being very, very, very prototypey, see it, I bent that one side, but that doesn't matter. It is a lot of work, but only because of these voltmeters. If you get rid of the voltmeters, like that's a lot of tiny holes, right? 7 holes for that, and then another hole, and then all of the soldering. Like that's a ton of soldering. I really like this, and the way, see, it has its own on-off switch, because this guy has an LED light and he drains power, so this is a completely separate circuit. So I used some kind of bracket, metal bracket. I had to cut it a bit, but see, I had to drill an extra hole there, but I put those screws in, and then I used another one of these, and it fits in great. It's very secure, very solid. You know, it's another way you could do it is you could drill a hole through the bottom there and then run it through and then through the back, but then I felt like that was stupid because there's going to be hooks out here, so there's a lot, like this far out, it sticks out, right? See these brackets and this hook, so there's already enough room anyways, so might as well put it out so you can actually work on it half decently, right? That looks really nice. The voltmeters, the next one's not going to have them probably. I'm probably going to take this one all apart once I'm done draining it down. I'm doing a test right now. I started at 29.2 volts. This charger works great. It charges up to 29.2 volts, and everything stays very well balanced. It's very safe. Give me your advice. Let me know what you think of this design. Is there something I could have done differently or improved on? I do appreciate your comments, and I do enjoy talking to you guys about this. Alright, thanks guys. Like, comment, subscribe, and have a great day. Bye. Both my soldering irons broke. Pieces of junk. But I do know why they broke. So it looks like a MOSFET transistor. It's some weird triac. It's basically some kind of transistor diode thingy, but it broke in both of them. Sweet. So I can't continue until I buy another one. I got this one for 30 bucks. It's pretty good. Came with all this stuff, so it's kind of neat. I showed my daughter how to do some wood burning art in the process. But yeah, pretty neat. I got this for like $5. It was like They try to charge you 20 bucks for this stuff. I got for $5, so it's really helpful. I'd recommend having a shrink wrap variety pack. It's kind of nice to have this big kit if you can get it for cheap. Like, always check used, never know. This was very integral to the whole process. Hot glue gun, definitely. 60-watt soldering iron. Anything less and you're gonna have troubles. Like, you can do it, it's fine. A lot of specialty fine tools. I had to use this, so yeah, this kit here, would recommend picking up a small kit like this for these tiny screws. These ones down here, you have to use a small set, and then I had to use an adapter. Yeah, all these I use them so much they sit out here all the time. Yeah, but this is basically what you would end up using. Right. I don't know if I'll ever get back to this and do it. I don't think it would ever actually work, to be honest. I'm gonna do everything else and then I'll come back to this, but basically, if you need a BMS that has a high drain, you did something horribly wrong. Like, you know, just literally, you should not need a high drain BMS. Do your batteries properly, right? Like, these things went wildly out of whack, and that was because I didn't organize them properly. So I did them so that, like, all 6s, 5s, 5, like, they all have to be almost the same per row, right? When you're building those big packs, you got to do it a bit different. It's a little confusing, but yeah, basically with these, you can quickly rearrange it if you made a mistake, which is really nice. I think I was talking to Chris about that. Alright, so this BMS, it came in the mail. I got 2 of them. Looks good. It's pretty nice. Charge port, power, and the battery. What's really neat is it's got this. Now this was it wired. When I first got this, I was like, what the hell? This makes no sense at all. And it's all in Chinese, so, you know, it doesn't make any sense. Apparently they make a version for polys as well, 3.2 volts. This is 3.7, I guess that's lithium. So let's look at this. So, right here. So this is an on-off to turn the BMS on and off. I don't know how exactly that works or makes sense, but yeah, that's pretty nice. Not a bad price, right? $32. Okay, so I bought this on January 21st, and it's February 4th. January 21st. So 7. So it took 2 weeks. What the? From China? It took 2 weeks to come in. Holy. That is a world record, ladies and gentlemen. Not bad. 25 bucks each. So these are the stats. Yeah, charges at 30 amps, discharges 60 amps. The only thing that really matters in here is this. Whoa, where'd it go? Balancing current 60 milliamps. So that's good. So I think I was talking to Chris, CRSBT. I know this was months ago, but he was saying, like, you can't talk to people about this stuff. You honestly can't. Like, they either have no clue what you're talking about and they just think it's fascinating and some kind of, like, oddity or perspective, or they just glaze over, or they think it's a waste of time. They're like, why would you need your own power at your house, right? Like, a lot of people are sheltered, or they only understand the world from where they sit comfortably. So it's fine. Like, it's nice talking to you guys, because I don't think I have a single person in the real world that I can talk to about this stuff. Like, I tried to explain to my parents, and they just, oh, okay, that's good. Like, you know, they're supportive. Like, they're not telling me that it's a waste of time, but, you know, this stuff isn't, it's too complicated for the average person. So it's really nice talking to you guys. I really appreciate it, because it's a lot of work, and you know, that's why I do these YouTube videos, is because, you know, it's the only way to really connect with other people that like you know, that like doing this stuff. So I really appreciate all your comments and feedback. Your criticisms are greatly appreciated. No matter what I say, or if it's negative or whatnot, even negative criticism, I'll figure out a way to, you know, make it constructive. So I really appreciate everything. So keep it up, and I'll keep pumping out the videos.